So now that we've got all the references to the objects that we want to instantiate set up in the editor, I'm going to go back in the track view class here, and in the init method, I'm going to start adding the instantiation methods. So first thing that we want to do is to make a reference to a game object. So I'm going to do a game object reference, which I'm going to call G. And then I'm going to start a new for each. It's usually said that it's better to use a for loop than a for each loop performance-wise. But as this is going to be done only just once, the for each is going to be just as good. And so I'm going to do integer b in track.beats. So for all the information, all the bits information that we have in the track, I want to instantiate a new object, and there I'm going to reference a new game object, and I'm going to do switch b, and so I'll say that case 0. So if the bit information is 0, it means that we want to do left. And again, totally arbitrary. I've decided that it would be left, down, up, right, but it could be anything. So I'll just say G equals left, and remember the left is a rect transform, so I need to access its game object property like this. And so this is going to be this, like that, this like so, and then I'll just do break like that, and then from there I can just go and copy paste, and copy paste for all the different cases. And then I'll say that if this is 1 or 2 or 3, then this is going to be left, down, up, and right. And there, instead of adding the case -1, I'll just use the default case. And so it means that if we, for some reason, we added some like other integer numbers that we do not support, then we would just default to the other object, and there we are going to use the empty object. So there basically I'm doing a loop. I'm creating a new reference to a game object. I'm selecting the game object based on the beat that I get, and now what I need to do is simply instantiate this object. So I'm going to do game object instantiate, and then I'll pass G, and then I'll pass the transform. So I'll say take the transform of this object like this. I'll pass the current transform of this object so that it gets instantiated in this object as a child of this object. And this, as we saw, because we have the other two components, the vertical layout group and the constant size feeder, this will automatically set up the view properly. So let's try that. And so now we've got this, we've got the reference to the track, we've got the reference to all the other objects. And so as I start, then I should get all the information set up properly. Now we can see this. And though one thing that we can see is that it obviously begins by the first object. So it adds the first one, then the second one, then the third one, and so on and so on and so on. So the issue that we have here is that the track is somehow reversed because we started adding it by the beginning. So there are two things that we could do to fix this. The first one is that we could simply replace the for each with a for loop and count backward from the end to the beginning. And the other way that we can do, and which I'm going to prefer because it'll later allow me to handle the object that we created, is to take a reference. So I'm going to make a reference to a transform, and I'm going to call it the view. and I'm going to say that it's going to be equal to this dot transform. So I'm making a reference to the transform of the object that I just created. And now I'm going to say view dot set as first sibling, like this. So it means that whenever I add an object, I will add it to the top of the hierarchy. And so by doing this, whenever I started this again, by doing this, then it will add it and take it to the top, because otherwise it's added to the bottom. So I add it and take it to the top, add it and take it to the top, and so on and so on. So this will simply reverse probably the track. And then what we can see is that the track will automatically begin by the pre-roll. Okay, so now I'm simply going to reset the default position of the track view to 0 on Y, so that it begins at the very beginning of the screen. And there again, what we can see is that this 3D UI system is fairly nice. It really allows us to say that we wanted this screen to tilt at 100 pixels from the bottom of the screen, or at 200 pixels, and so on. And then we really get to tell where the track is going to end up on the resulting 2D screen. Now that we've populated the track with all the bits information, we want to have the track to scroll automatically toward the camera, and this is what we're going to be touching on the next video.